Transmissions is a company that strongly believes in this, and at the beginning of this year, they began their journey towards lean manufacturing. Now, if you're not familiar with Jasper Engines, what they do is they remanufacture gas and diesel engines, transmissions, and differentials. They were founded in 1942 by a man with the name of Alvin Ruxer. During this time, Mr. Ruxer owned his own Ford agency, and just like every other automotive company, was struggling to keep his inventory at the proper level due to World War II. To fix this, Mr. Ruxer dedicated a small room in the back of his agency, just measuring 12 feet by 20 feet wide, and began to remanufacture gas engines. Today, Jasper Engines and Transmissions has approximately 45 distribution centers across the country. Now, like I said earlier, at the beginning of this year, they began their journey towards lean manufacturing. They decided to introduce the lean principles in their gas engines department. As this year went on, they decided it was time to introduce the lean principles in a different area, the tool and die department. They asked us if we could come in and help them with their transition towards lean manufacturing. We decided to focus on the CAM area, which is located in the tool and die department. Reason being is that this area brings in the most income for the department. Now, if you don't know what a CAM looks like or even does, we do have some examples. Here's a picture along with some actual cams. Now, there are a high variety of different types of cams depending on your make and model of your vehicle. The ones we brought in today are called 3-lobe cams. Some things to know, the cam that's furthest to the left, this is what the cam looks like when it comes into the tool and die department to be remanufactured. The one in the middle is what it looks like after our process is ended. You can see there's welding in the middle here. And then finally, the one on the furthest right, that's what it looks like right before it gets installed into the engine. Some more things to know. As you see, there are multiple lobes around the cam. These lobes are egg-shaped and offset just a little bit from the one in front of it and behind it. We also have a short animation for you to kind of show you how a cam works inside the engine. Quick little preview. What's going to happen in this animation is here's the cam. It is going to rotate. As it rotates, the lobe in front will open up the intake valve, which allows the necessary gases to enter the piston. The cam will continue to rotate, and the engine will combust, and the lobe that's located behind the first lobe will open up the exhaust valves, letting all the gases out. We'll show it one more time for you. Now I'll pass it over to David, and he will go through the CAM process and our process observations.
As Colin mentioned earlier, this area of the tool and die department brings in a lot of income at Jasper Engines, so it was important for us to implement lean in this area. So the first thing we had to do was to understand the process. As you can see, it's a pretty small area. It consists of a lathe used for cam taping and cam painting, a sandblaster, a spray weld room, wire wheel and grinder area, and a lathe used for cutting the cams. So basically what happens is a worker comes in each day and takes a look at the daily demand. And the daily demand can fluctuate between 14 or 35 cams a day, but usually stays pretty consistent at 35 cams a day. So after they have figured out the daily demand, they'll come over to the incoming cart, takes a set of 7 cams, and put it on a cart similar to this one, and wheels it over to the first lathe, and they'll tape the cams. And after they've done taping the cams, they'll wheel it over to the sandblaster, and this is where they'll sandblast the cams in sets of 3, 2, and 2. they're done sandblasting cams, they'll bring it back to the first lane. And this is where they'll peel the tape off and paint the cams individually. And after they're done with that, they'll wheel it over to the welding room. And this is where the workers will put on their PPE, personal protective equipment, which includes a lab coat, a welding mask, a set of fire-resistant gloves, and 2 pairs of ear protection. And then they'll thermal arc weld the cams to ensure proper diameter size. After they're done with that, they'll wheel it over to the wire wheel and grinder, and this is where they'll smooth the ends of the cams. The final step is to wheel it over to the lathe, and they'll cut the cams in certain parts. After that, they'll finally put it on the outgoing cart, which is located right here. The final and last thing the worker has to do is to come over to record the finished time of the set of 7 cams. And the recordable board is currently located outside the area in the aisleways. After we understood the process, we began to conduct our process observations. We define process observations as an analysis of a task using a timekeeping device to record the efficiency with which an industrial operation is performed. For our process observations, we broke it down into 3 areas, and we broke it down to simple steps. The first area would consist of getting 7 cams for the income cart, taping the cams individually, taking the cams to sandblaster and blasting them individually, removing the tape, and painting the cams individually. The second area would consist of taking cams to the welding area, putting on the protective equipment, spray welding the cams individually, removing the personal protective equipment, and then finally taking cart to the next station. The third area would consist of the grinding and wire wheel work area, cutting the cams individually, pushing the carts to the outgoing cart, stamping the cams in place on the outgoing cart, and recording the number of cams. And as a note, we use the second lowest repeatable time as Jasper Engine's request to use for our calculations. And now I'll let Colin talk about the value stream maps we created for this process.
So one of the tools you use when making a transition to lean manufacturing is a value stream map. The purpose of the value stream map is to map the whole process starting with your supplier and going all the way to your customer. As you can see, there's quite a bit of different symbols, and each one means a little bit different. So a quick little value stream map 101 here. The 2 squares at the top indicate your supplier and customer. The 2 symbols that look like a truck are your incoming and outgoing shipments. Your triangles that have an eye in the middle, that is where in your process you have inventory buildup. And then finally, these rectangles here represents 1 step in your whole process. Kind of going more in depth into the symbol that looks like, that represents 1 step of your process. Additional information is stored in here. Here you want to capture your cycle time of the area, the changeover time, if there is one, the uptime, or the percentage amount of time that that position is operational, how many shifts operate that area, and how long those shifts are. So when filling out Jasper Engine's current value stream map, there is a few things we had to take in consideration. The first being the takt time. What the takt time is how fast they have to produce 1 piece of product, which is in this case 1 can. To find that, we had to find the available time, and we divided that by the daily demand. We got our available time by taking what they operate in now. Currently, they operate in 9-hour shifts with 2 15-minute breaks and 1 30-minute break. That gave us an available time per day for 480 minutes. To find our daily demand, we went back in their history books and found that they had never had a higher demand than 35 cams per day. So that was the the number we used. Plugging those numbers into our equation there, we came up with a tag time of 13.7 minutes. Something to make sure to add here, that does not mean they have to have their whole process done in 13.7 minutes. That's assuming that one cam is in each position and it has to move to the next step in 13.7 minutes. So quickly going through Jasper Engine's value stream map here. It starts at the cam department. They will send us 35 cams in a day's time. They get shipments at 8:45, 10 o'clock, 11:30, 1:30, and 3. We found these cycle times by doing process observations. For the cam taping, it takes them 3.2 minutes. For blasting, it takes 1 minute. Paper removal and painting, it takes 2.7 minutes. Spray welding is 6.6 minutes. And lathe cutting is 4.8 minutes. Giving them a total process time of 18.3 minutes. And moving along, they have shipments that are going out. At the same time, they get shipments coming in at 8:45, 10, 11:30, 1:30, and 3. Excuse me. Okay. So the next step, or another tool that you use when transitioning to lean manufacturing, is called 5S. What 5S stands for is sort, set in place, shine, standardize, and sustain. This tool is to help keep the managers and employers keep the area organized and clean. This slide is kind of an overview of the area before 5S was implemented. Some things to point out is there's some items laying in the bottom of a cart. There's drinks in various places around the work area. There's not very much labeled, and believe it or not, this drum was empty and just kind of sitting back there. So the next few slides are kind of before and after pictures of when 5S was implemented. Here we have the first lathe where they paint and tape the cans. You can see that paint splattered everywhere, and there's a sign that's kind of sitting back there. We went through, cleaned the area up, labeled all the tools, and actually outlined the tools. So, for example, if that hammer right here was missing, there would be an outline of it, and the employee would know their hammer is gone. This picture is in the spray welding area. The tools that they used, they had just sitting underneath the spray welding hood. We installed a shadow board and gave each tool their own specific home. In their area, they also had a cabinet back there. It was labeled, but nothing really fit their label, and there was things just thrown in there. And it was outside the work area. We went through and found the things that the cam area absolutely needed and was necessary to be in the area. We went and got a second cabinet, placed it in the area, organized it, placed the things that the area absolutely needed to operate, and then gave a nice place to store their personal protection equipment. And the last picture we have on the 5S area is this is the second lathe. You can see that nothing is labeled. This is kind of cluttered. Again, we went through, labeled everything, and found what was necessary to be there. So after 5S'ing, the next step was to create a future value stream map. The future value stream map has the same concept as the current value stream map, only this time you put all your improvement ideas in what's called a Kaizen blast, which are these right here. Some of the things we suggested to them was moving the incoming cart to the beginning of the process, moving the outgoing cart to the end of the process, adding a door to the side of the soda blaster so they wouldn't have to walk around to place the cams in. We also suggested installing multiple shadow boards throughout the area. We suggested that they should look into a manufacturing forecasting system so they will be able to tell what types of cams are coming in the next day, and how many of those cams are coming in. And then an ultimate goal that we thought was appropriate for this area was to move to a one-piece flow operation. So after we created this, we sat down with our liaison, some team leaders, and the 2 employees of the area, and suggested to them. Taking a step back, also in the future value stream map, we also included if the company would implement all of our improvement ideas, how much that would decrease the cycle time. So going through here, if they would implement all of our ideas, we believe that the cam taping, the cycle time would be reduced to 1.4 minutes. The sandblaster would be reduced to a half a minute. The tape removal and painting would reduce to 2.4 minutes. The spray welding area would reduce a full minute down to 5.6 minutes. And then last, the lathe cutting down to 4.5, giving them a process time of 14.4. With that process time, it makes this area possible to have a one person operate this area. And they can move that second person to a different area of the department where he is more needed. So after coming up with all our ideas and suggestions, we sat down with our liaison and the team leaders and the employees to see their thoughts. Some of the things they wanted to implement right away, and some of the things they did not want to implement at this time. The things they wanted to implement right away was implementing 5S, moving the incoming and outgoing cart to the proper area, and installing the door on the other side of the soda blaster. Some things they did not want to implement at this time was they did not want to make this a one-piece flow operation, and they did not want to go to a one-person work area. Now I'm going to pass you back to David, and he's going to go through our economic analysis and close us out.
After finalizing our suggestions, we conducted an economic analysis. The analysis shows both the costs and the savings before and after our lean implementation. The costs include expenses paid to the consulting engineer, calculated based on the $100 per hour pay rate for 15 hours of work, which comes up to about $1,500. The labor paid to 2 students with a pay rate of $8 an hour with 60 hours work, which comes up to about $960. The material costs included with this would be a cabinet, a board holder made out of steel, and a gun fixture, which is estimated to be about $200, which brings our total cost to be around $2,660. Besides the savings of time, we had a savings on money. If they were to implement our suggestion of reallocating that one worker at a pay rate of $10 an hour, 40 hours a week, 15 hours a week of overtime, 50 weeks a year, we could be saving them a total of $23,750. Overall, the project was a success. Jasper Engines has been cooperative throughout our project. They got the employees and upper management involved, and we were able to finish this project ahead of time. They realized the importance to continuously improve, and in the end, they reduced their lead time and waste while increasing their productivity and money. I believe Jasper Engines can use our project in the future as an example to move towards a true lean process. And at this time, we would like to thank Jasper Engines for letting us conduct our senior project, Dave Sun for helping us gather information and answering any questions we had, Donna Moore for her helpful reminders throughout the semester, Dr. McDonald for answering our questions and helped us along the way, Dr. Mitchell and all of the College of Engineering faculty and staff for helping us throughout our collegiate career. And now we would be glad to take any of your questions.
All right, questions?
Nice job. On your value stream map, there was a production lead time, it was a bigger number. And then like a cycle time below it. Could you explain what those were?
Yes, the production lead time is, back to the slide. Okay, the production lead time, this time takes into the account all the inventory that is sitting here. The processing time just takes into account how long it takes to actually do the process.
Colin, I don't know if you want to stay with this one or go to the future value stream map, but your lean manufacturing actually just improved the cycle times. Do you think another lean manufacturing step would be improving the inventory setup time? Because they're staying at 45 and 108 minutes throughout the whole process. Do you think you can improve that?
Yes, there is room for improvement there. But the thing with the value stream map is it's like a screenshot of how the area. So when we made this, we went out there and took a screenshot of the area and how it is right at that moment. The only time in this area that there is really inventory built up is at the beginning of the day and at the end of the day. That's because they prep for the next day at the end of the day. So I guess it's kind of misleading because it says there's inventory there, but there's not inventory there all the time, just when they prep for the next day.
Any other questions? All right, let's give them a hand.